Well, good afternoon, good morning, good evening to anyone, wherever you may be. Thanks so much for joining us here live for the one and only Serverless Office Hours. We are streaming. We're back on the AWS Twitch channel this week, so welcome if you're joining us from there. And we're also on the YouTube Serverless Land page and also via LinkedIn Live. My name's Julian Wood. I'm a developer advocate for Serverless here at AWS. And I'm joined by two awesome people, Balwant Bobili and Jatin Singla, and we're going to be talking all about time series databases and things. So Balwant, tell us, how on earth did you manage to get into the world of time series databases at AWS?
Sure. Hi, everyone. I'm Balwant. I'm a Timestream specialist solution architect here at AWS. I'm based out of Utah, and which is pretty famous for skiing. I specifically love cloud and cloud databases. And like when I was in like my previous company, I always worked with like a cloud AWS databases, and that got passionate about me, and like I jumped into AWS, and like I got an opportunity here as like time series data. So we have like a couple of engines here, and I specifically work on Timestream for live analytics.
Cool, excellent. Well, great to have you. And Jatin Singla, you're welcome to Serverless Office Hours as well. Yeah, you're a software development manager, so you're literally building time series databases. Yeah, what's your journey to AWS?
Hey, thank you, Julian. So hi, my name is Jatin. So I've been overall, I've been working in software industry for almost 10 years now. And currently I'm software development manager with Amazon Timestream. So before joining AWS Timestream, I had the opportunity to use AWS products, the databases. So I've always been interested about the scale and to see behind the scenes, like how services operate at that scale. So it was always in my mind to actually get a chance to work on those. And 4 years ago, I got the opportunity to actually work at Timestream. So we grabbed that, and yeah, we launched Timestream in 2020 as part of that launch team. So it has been
cool, excellent. Well, we're going to be talking a lot about time series databases today, but just before that, looking back over the past week, sort of in the world of serverless, if that makes any sense. Last week's stream was all about sort of education, and Rosius and Dimopur were talking all about the EduCloud Academy. Yeah, such a fascinating platform that he's built, a serverless platform as well, to teach the world about serverless. So yeah, that is on our youtube.com/serverless land page, along with all other Serverless Office Hours episodes. And yeah, just a great use case of showing how they've got some real experts who put together these live workshops that you can do. A whole bunch of them are free. So yeah, really useful to look out for EduCloud Academy and see Rosius and explain the philosophy behind it, which was super interesting. In terms of some what's new kind of thing, well, the top one's actually quite interesting. Amazon S3 allows you to tee up with Amazon Guard Duty, so it allows you to detect malware in new object uploads. So you upload something to S3 and Amazon Guard Duty jumps in and checks for malware automatically. That is super useful in my book. So yeah, love that as well. Data Firehose, if that's sort of in the Kinesis world. So if you're talking moving data around, yeah, integration with secrets managers, that makes it much easier to be able to integrate those two services. In terms of some service blog posts, sorry, I'm chewing I actually went to the dentist recently, literally today. I was a bit of a late running for office hours. So I've got some sort of crunchy stuff, you know, when you go to the dentist, and probably didn't wash my teeth up. But anyway, that is a slight sidebar. So if I'm crunching into the microphone, you know what that is. Well, it feels like crunching in my head. But anyway, back to serverless things. So Mesh Sedel-Keating on my extended team has put together a blog post on using customer managed keys. So this is with ECS workloads on Fargate. Obviously, security, we always say that is job zero here at AWS. Yeah, there's a big push along with a lot of the service teams to implement customer managed keys, so you can have your own keys in addition as another option for many of the AWS managed keys. So yeah, a good blog post to be able to explain how all of that works. It is AWS Summit season at the moment. The Japan Summit is on this week, so if you're anywhere near Tokyo, that would be great to join. A whole bunch of other summits coming up, as you can see on the screen, and some more have been added actually. Since last week, Bogota and Taipei are new summits that have been added to the list that I was not aware of. So yeah, summits, they're free technical days, lots of good content. I know lots of teams are working very hard to put on the best day they can. So yeah, lots of really good talks, workshops and things like that at the various summits. So yeah, have a look at this one near you and you can get up to date on AWS. But yeah, sort of heading back to Balwant and Jatin. But before we quite do, remember we are live here in Office Hours. So please, send us your questions, send us your comments. We love to know even where you're joining us from. We have got Honey Plum is Cool saying hello, joining us from Twitch. Thank you very much. With an interesting question. when you guys having AWS in South Africa? Well, we do have AWS in South Africa. In fact, EC2 was born in Cape Town, if you think of it. That's quite an interesting origin story. And yeah, we do have a region in Cape Town as well. I'm originally from South Africa, from Cape Town, and I have done some serverless things in there as well. So if you think that AWS is not in South Africa, let alone Cape Town, yeah, there is actually a region in Cape Town. So yeah, remember, send us your questions, your comments, let us know where you're from, any kind of things. If you want to learn about time series databases, we'd love to answer your questions for you as we are live. But first sort of tee up question, and I'll head over to Balwant first. Balwant, what is time series and how does it fit to storing it in the database? What even is time series data?
Yeah, sure. Jitin, do you want to take that?
Sure. Yeah.
I meant to go to Jatin first, and then I messed up. Anyway, Jatin,
Yeah, no,
yes.
No
Wrong
worries.
timing. Bad joke. But yeah, Jatin, tell us about time series.
Uli, are you able to see my screen? Just one.
Yes, let me add that up. There we go.
Okay, cool.
So yes, as the name suggests, a time series database is a database which is optimized and purpose built for time series data. Now, as going to the time series data, basically any data which has a timestamp associated with can be termed as a time series data. For example, just consider a device which is emitting some temperature readings somewhere. So with temperature reading is emitting a timestamp at which the temperature is getting recorded. So that can be an example of time series.
Okay, so it's basically any sort of structured / semi-structured data, or probably structured data, seeing it is landing up in the database, that has a field that is time. So, I mean, that could be logs, it could be an IoT device, it could be chat, it could be, I mean, I think a whole bunch of things that, and I suppose the time is sort of integral to the actual data that you're being stored, not necessarily just a log for informational services or metadata stuff. This will be, a temperature was taken at a particular time. And so, and I think the series then means it obviously needs to be ordered as well. Is that part of the sort of understanding of time series?
So series basically would mean that these events or the time series data points will keep getting emitted at some certain periodicity.
Okay.
So it basically ends up become a series.
Okay, that makes sense.
I would like to add that one more point there. Yeah. So in general, like we have like multiple use cases for like time series, right? Like it could be like IoT, one you mentioned and like Jatin mentioned, and the other use cases where we have seen is in web traffic. Let's say like you have a web application and you want to track the like what kind of clicks are being performed on the user, like whether like let's say like e-commerce website, they're trying to add like new products. So you basically understand the customer journey and you can make recommendation on that. So you can store that kind of data in Amazon Timestream for live analytics. And the other use cases are such as financial use cases where you have like a portfolio data or like market data that, and you want to build a UI on top of it. Like that's one of the common use cases we see. And other common use cases are like DevOps use cases where you're managing a fleet of instances, where you're monitoring CPU, memory, or like other hardware metrics. So that's where like time series data, you can store that in Amazon Timestream for analytics and run some analyticals on top of it, or visualize the data based on the use case.
Okay, and if someone is thinking, well, I could just use a NoSQL database, I could use a relational database, why would you think a different database family is needed for time series data?
So yeah, I can take that. So for example, like I think as we said, that Timestream databases are purpose built for time series use cases. So like there are certain aspects to it as data keeps on aging. So generally we have to have some kind of tiering use cases into it, like how so most of the use cases are not that much interested in the historical data as much they are interested in the recent data. So the database is purpose built for those kind of use cases, which these kind of features are ingrained into the database. And then performance is the major aspect to it. Like with time series database, the business insights or analytics that needs to be done, like the use cases that require this will, like the performance that Timestream databases provides cannot be matched by the generic databases. So yeah, going over to the so Amazon Timestream for live analytics is one of the offerings. Amazon has generally two offerings for Timestream databases. One is Amazon Timestream for live analytics. Another is Amazon Timestream for InfluxDB. So these two offerings cater to different types of use cases. Today we talking about the recent new introductions, new features that we have launched as part of Amazon Timestream for Live Analytics. So Amazon Timestream for Live Analytics is fast, scalable, fully managed, and purpose-built time series database that makes it easy to store and analyze trillions of events per day. And it also saves you cost and time to manage the life cycle of time series database. It automatically takes care of managing the life cycle and tearing the data and pruning the data out of the window for the ones that you don't need it.
Okay, so Amazon Timestream is this sort of a suite of products together, and InfluxDB, which is an open source database, also a time series database. So there's Timestream for InfluxDB and then Timestream for Live Analytics. The Live Analytics part, I'm actually not aware before of the Live Analytics part. Is that an AWS created time series database, or is this a version of some other open source or something database that AWS is running on your behalf?
So this is AWS. Sure, go ahead.
So originally Timestream was like a single engine, and now it has become a product, and it has like two services in it. Like one is like Live Analytics, which is an original Timestream, and now we have the other engine, which is like managed Influx. We have taken the open source version of Influx and we are providing it as a managed service. If you're familiar with RDS or like any other like a server version services in AWS, so that's what we do with like we have taken the open source version. And one thing to highlight there is like we are not alone on the boat on that side as well. Like we are in partner with Influx Data on it. So like why do we have this for coming to your question, like why like Live Analytics is completely built from scratch, so it's not like an open source service we have taken like similar to InfluxDB. It's purely built from scratch, and it the beauty of like it is so generally like I'm trying to club your like previous question also. Why choose like a purpose-built time series database, right? So we have like a lot of with what happens with time stream databases is there is like a lot of millions of trillions of events coming in, so we scale on the fly. We have seen customers like ingesting data like 100 records this day, and like tomorrow they have like millions of records. We automatically scale it, and on top of it they run some interpolations and smoothing functions which are like by default provided as part of this time series databases, so that makes easy for analyzing the time series data.
Okay, cool. That's interesting. It's interesting to know. I think all of these services that are ridiculously high scale, I think of a way to move data from one place to another is Amazon Kinesis as well. And it has got partition and sharding and everything. That's all about high volume moving of data around. And sometimes you need to, because the scale is so huge, it's worth creating a cloud optimized version of that. And so I can see, for a time series database, which is also about storing large amounts of data very quickly and being able to analyze it. Building a database engine from scratch is worth doing. That's a big job. So I can imagine this must be pretty impressive.
Yep.
So I think we can go over the key attributes of for Amazon Timestream for Live Analytics. So some of the key ones are like, especially it is serverless and easy to use. For a customer end user, there is no servers to manage. And as the needs of customers' application change, as the applications grow in scale, Timestream for Live Analytics automatically scales limitlessly to adjust capacity. And because there is no underlying infrastructure to manage, end users can focus on building and optimizing their applications. And there are no software patches, no indexes, and no database optimizations needs to be handled. Everything is getting handled automatically by the service. And especially it is also purpose built for time series data, as we are saying. So one of the key attributes is the storage tiering part of it. So we Timestream for Live Analytics provides two storage tiers. One is the memory store and the magnetic store. So memory store is built for the recent data that is coming into the database, and magnetic store is for the historical data, and it automatically takes care of tearing the data from memory store to magnetic store as the data ages, and that can be configured by the user defined policies. And also the query layer is adaptive, and user don't need any disparate tools to be able to access data from memory tier and magnetic tier. Users can write combined SQL queries, and without having to specify data locations, it transparently accesses the data in combination from both the tiers as the query demands. And it is also having these time series catered feature functionality such as smoothing, approximations, interpolation, integrals, derivatives, all those complex functionalities, even some aggregated window functions and stuff like that, which are generally needed for time series kind of use cases to gather more insights for their business use cases.
So that's also the thing you were mentioning earlier about using a time series database, because you generally want to access data that's more recent rather than older data. And so that more recent data basically stays in memory, and so that is obviously super fast and efficient to analyze and read from that. And then over time, it automatically ages out to some different storage mechanism, which obviously have a good impact on costs and just makes the service run more efficiently. Okay.
Yes, exactly. I think you covered it. So memory store is purpose built for fast point in time queries, and it is and magnetic store is it's kind of cheaper in terms of storing the data in magnetic store. It is purpose built for fast analytical queries. So if you want to scan like some, let's say, scan years of data and build some insights from that, you can run those kind of queries from magnetic store. Memory store is for like if you want to fetch data for last 1 hour or so and basically gather some recent insights and anomaly detection on that. Memory store is useful for those kind of cases. And then another aspect is the security, like because it has been built from the grounds up, all the data that we keep, we store at rest, or we like data in transition, everything is encrypted using AWS KMS, using custom managed keys. So security is the number one priority for everything that we do here at Amazon. So that is inbuilt into the time series for live analytics solution as well. And as we have been, we launched Timestream for live analytics publicly in September 2020. Because of the serverless nature of the system and architecture, all the continuous releases that we have been doing over the years, there is no maintenance or no downtime required, as is for the all serverless solutions. So some of the major launches that we have done in last few years. Bharat, if you can move to the next slide, maybe.
Yep.
So we have been continuously doing enhancements to the product by learning from customers how they're using it, or just adding some more optimizations to get better performance, better scale to the customers. So some of the recent ones that we have done is schedule queries. Schedule query is a feature which provides functionality for calculating and storing aggregates, rollups, and any other kind of pre-processing data typically used for like dashboardings, business reports, or ad hoc analytics. Schedule queries makes real-time analytics more performant and also cost effective. So we had these use cases where, for example, we were saying like customers have their data coming in at nanosecond granularity, because nanosecond is the lowest granularity that Timestream supports. So some customers had their data coming in at nanosecond granularity, and even if you have to scan last 1 hour of data, given every nanosecond you have one data point coming in, there'll be a large number of data points that we'll need to fetch and query. So schedule queries help build aggregates on top of those nanoseconds. So generally for analytics, we can just basically take some decisions based on the second level aggregates or maybe minute level aggregates. The schedule query helps pre-compute those kind of aggregates, keep them materialized in the time series database, and users can just query those minutely aggregates, and the queries are much faster and very cheap as well compared to the nanosecond.
Nanosecond is crazy. So I mean, thinking of the millisecond, how quick that is as well. But I mean, nanosecond. So I mean, an example would be, you are doing temperature readings, or some temperature readings from some IoT device. Now maybe each nanosecond, maybe that's a bit of a contrived example, but I mean, you could then have 1,000 temperature readings come in, and that's literally within 1 second, and just then do an aggregate over that, find the top temperature one, and then pass that on to another system. That's a sort of efficient way that you can do sort of sliding time windows to be able to do analytics really quickly. And if it's in memory, wow, super fast. Nanosecond is amazing.
Yep. And the second recent feature that we have launched is customer-defined partition keys. So this is a feature that enables customers to choose their own partitioning key for their tables. So partitioning in general is a concept where, it's a technique which is used to distribute data across multiple physical storage units. allowing for faster and more efficient data retrieval. So with this particular feature, customers can create a partitioning schema that is more suited for their own query patterns and use cases. So with the help of this, customers can basically optimize their data models, improve their query performance and cost. So this have been a super hit feature that we have recently launched, and customers have gained in terms of query performance and make their queries much cheaper as well to get what they need from out of the database.
So I suppose at this massive scale, I mean, if you're talking on the data moving things like Kinesis and Kafka also have partitions, because that's a way that you can control how data is sort of sharded between things. And even DynamoDB has, the concept of some partitioning behind the hood. And in a similar way, you don't really need to know to manage the individual storage kind of things. It's just a way that you can increase your scale massively, because these are ridiculously high scale systems.
Yep, makes sense. So yeah, and Amazon Timestream for Live Analytics also supports the data protection by using AWS backups. And we recently introduced the feature for batch load, where customers are able to directly ingest data to Timestream from their data in S3. And similarly, we have also launched unload functionality, where customers can directly export the data to S3. The data that they have in Timestream can directly be exported to S3. So now I think learning from the users, what we have seen is like Timestream customers need real-time insights for their time-sensitive data. So to be able to get to the near real-time insights, customers generally require some data pipeline solution where first their end devices will be streaming their data to some streaming solution, and from that streaming solution, some processing will be needed to get the data to Amazon Timestream. So generally, that customers often needed to have this processing solution managed by either AWS Lambda or Apache Flink adapters, or undifferentiated yet some specialized code to transfer time series data from streams to Timestream. So this kind of added overhead for customers for infra maintenance and code maintenance, and added some extra developer time to get the data into Timestream itself. So we recognize this problem, and recently, like just a couple of weeks ago, we launched a feature which kind of fully manages this pipeline on behalf of customers. So now Amazon Timestream for Live Analytics integrates with EventBridge Pipes to streamline this ingestion. So customers will just need to specify that this is the source of the data, and Timestream, this is a table in Timestream that the data should be going to. All the in-between pre-processing and processing will be taken care by the solution itself without customers having to maintain it. So yeah, having said this, I'll hand over this to Balwant. I think Balwant has a really cool demo to showcase the boundaries of the feature.
Cool. Awesome. So just before we get to the demo, so this is in effect replacing, you still have something like Kinesis data streams, data coming in, and obviously that's a transport mechanism. And previously you would either have a Lambda function which would have to read that, which is fine, or you'd have Apache Flink which would read that, which is fine, and then that would send it on to Timestream for Live Analytics. And now you can just replace that and insert EventBridge Pipes, which you don't have to run your own code to manage that. In fact, it's using the same polars under the hood as Lambda would be using, and so it's just a simpler way to integrate things. I know obviously we'll go into some of the details of what EventBridge Pipes does, but is this just then a simplicity story of just using another managed service to move data quickly across?
Yes.
Yeah.
Go ahead.
Exactly.
Okay, we just had one or two questions that have come in while we were talking about what Timestream is. And Nacho Pants, love the Twitter handle. That is so cool. Thanks for joining us via Twitch. Does this support UDP as a protocol? And then there was another sort of follow-on. To be clear, let's say you have agents pushing to Timestream faster than it can handle. What happens? Does it support anything asynchronous? Okay, that's maybe another part of a question. But yeah, I mean, how does one write, without using the integrations we're talking about today, how does one normally write things to Timestream for Live Analytics? Is there an SDK? How does stuff get into Timestream for Analytics? And is there anyone know if there is a UDP option and something sort of asynchronous? I suppose this is asynchronous, this demo we're about to see. But yeah, any info on UDP?
Amazon Times, we can use Java SDK, Python, Go, CLIs. So all of those generic options are available. I don't have the particular answer about the UDP.
Okay.
I'll let to
Yeah, I'll have a look, or we can get back to you. I don't believe, I don't believe it has UDP support. I suppose the UDP support is then you're just going to drop records arriving. UDP is a lossless protocol, so if records don't arrive, that's the way it is. It's just going to drop them. So I suppose that's a different kind of thing. Here's thanks, Nachapan, for coming back. Thanks, gents. InfluxDB used to support UDP support, and it got removed recently. Interesting. Good to know. So yeah, maybe UDP isn't. It does sound strange to have UDP as a supported protocol for a database, because especially when you're writing anything, then you've got no guarantee of TCP delivery. So anyway, let's Balwant, what would you like to show us for a demo?
Yeah, before showing the demo, I just wanted to mention what's an EventBridge Pipes. I just try to give a brief introduction about EventBridge Pipes. So it's a point-to-point integration, with supported source and supported targets. So with this recent launch, we have added Amazon Timestream for live analytics as a new target. So with this new launch, what happens is before, as Julian or Jatin was pointing out, there was custom code Apache link adapter you have to maintain, and there is some custom changes you have to do as part of the process. So that's why EventBridge is a low code, no code configuration based solution to ingest the data in Timestream for analytics. And another benefit here we see is just not the Kinesis data streams. Now you can use EventBridge Pipes to ingest the data from different sources such as Amazon DynamoDB, Amazon MQ, Amazon SQS, Simple Queue services. Okay. Before moving into the demo, I'll quickly walk through what I want to show as part of the demo. So I'll show you within few clicks how we can create the database and table in Timestream for live analytics. Then I'll go ahead and set up the EventBridge Pipes, choosing Kinesis data streams as a source and live analytics as a target. Then we'll ingest the data into Kinesis data streams using KDG. KDG stands for Kinesis Data Generator. So it's a simplified UI to send test data. And you can create some templates and generate random values and send it to streams. And then based on our EventBridge configuration, it will pick the data from streams and then ingest the data into live analytics. And then we can go ahead and query the live analytics database to see the data is coming in. Okay. With that,
Kinesis Data Generator is great. I've done a bunch of stuff with Kinesis, and one of the things when you're trying to generate a whole bunch of data, because this obviously runs at scale, you need to generate a whole bunch of data, and you're like, how am I going to do that? Start writing some Python, Node, Java code to be able to iterate through that. That's just a little extra thing you don't have to do. So Kinesis Data Generator is super good, and it's all open source on AWS Labs on GitHub. So have a look.
Absolutely right. We can if you have shared the link, so that absolutely helps. If you're onboarding to the Timestream, so instead of sending the data from your application, you can just use Kinesis Data Generator to send sample of your data and start querying and make sure it fits your use case. So that's a pretty fast way to get started. So having said that, let me go ahead and show you within few clicks how we can create a database and table in Timestream for live analytics. So I'm already on the AWS console. I'm on the Timestream page. Then all I have to do is come to the database pages and click on create database. So there are a couple of options here, standard database and sample database. I'm going to choose standard database for now. Sample database basically helps you to have a sample data generated for IoT or DevOps, where you can start querying the data if you want to get familiar with Timestream. But for this one, I'll just choose a standard database. And I'm going to give the name as vehicle metrics because I plan to ingest vehicle data as part of the KDG. Okay. And as Jatin was highlighting about encryption, so we have KMS key support. So for now, I'm just choosing the default key. But if you have a customer managed key that you wanted to use for your database, you can absolutely do that. And for tagging is an optional, so I'm skipping that for now. So I'll just within one few seconds we were able to create the database. With that, I can go into my database.
You actually only gave it a name. That was literally the only thing you needed to do. Give it a name.
Exactly. Right? If you remember past traditional databases, it used to take a lot of time to onboard the stuff. So this is kind of becomes easy with serverless. So I went to the database tab, and now I can go ahead and start creating the table. Okay. I'll give vehicle metrics again. and just mention as table. Okay. So there is no schema structure. It's the time stream is not a rigid schema. It is a schema on the fly. But one thing, yeah, as Chetan was highlighting, we would you can use like customer defined partition key. So there is a default partitioning also available in timestream. So that is based on like measure underscore name column, which is a default column in timestream. But what we recommend is if you have an I cardinality column for your table and which is often used for querying, then you can use the customer defined partition key. So before choosing the customer defined partitioning, I would like to explain a couple of concepts in timestream. Pretty basic. So there is dimensions and measures in timestream. So dimensions, going back to Julian's example, there is a device that's capturing humidity and temperature, right? So the device ID or like whatever the metadata of the data becomes a dimension, and the values which are changing over the time. In this case, humidity or temperature. So those become the measures. So another example would be an easy example would be, let's say you're capturing metrics for vehicle. Okay, the vehicle ID can be dimension, and whatever you're capturing like a battery level or engine status or door status, whatever that you're capturing becomes the measures. So the values that are changing over the time where you want to perform mathematical operations or any kind of aggregations, those become the measures. So since I'm using I wanted to ingest like uh, vehicle details, I'm going to choose vehicle underscore ID as my partition key. For moving on to the data retention, as Chetan was highlighting about memory store and retention, magnetic store retention. So I would like to mention that there is no difference. One is not more optimized than other. Memory is designed for point in time queries and dashboarding queries. Magnetic is more designed for analytical queries, and it's obviously comes with like cheaper storage and archival system. Okay, I'll keep those values as default. So 12 hours and 10 years, and you can all the way go to like 200 years for the magnetic store retention.
200
And
years. Wow, that's amazing.
yep. So you can enable magnetic storage, right? What does this mean is so you can directly have, so some use cases where there is like late arriving data, so devices go offline, or like some use cases the systems go offline and they send the data later. So if it's outside the memory store retention, if you expect that that is something similar to your use case, then you can enable magnetic storage rights also. I'm keeping is enabled for now. And there is backup settings as well, like Jatin was pointing about AWS backups integration. You can turn on the backups as part of the table creation itself. But for now, I'm just for this demo, I'm just keeping that part, and you can add the tags if needed. Okay. If you see, it was again few clicks. It's just that my explanation took a while, just making sure you understand that part. But it was pretty easy to create the table also. So now we can. I'm in the tables tab now. I can start querying the table. Okay. So we have a SQL support again, like as Chetan highlighted. So there is a query editor also you can use in the UI, and you can start running the queries as you ingest the data. So yeah, there is no surprise. We haven't ingested any data yet, so there is 0 rows as of now. Let's go ahead and set up the EventBridge pipes and start, and then we can go ahead and ingest the data from KDG and come back here to validate the data. Okay. So instead of like opening like new tab, so I already have a EventBridge pipes navigation tab here from the management tools within Timestream page. So I can just click this and start creating the pipes. Okay, I'll give the pipe name as vehicle metrics. For source, I'll choose Kinesis as my source. And I already created a Kinesis stream where I wanted to ingest the data. So I'll choose that stream, and I'll keep the rest of the options. Oh no, I'll actually choose batch size 100. That's the maximum batch size supported if you choose Kinesis as a source. And for on partial batch item failures, it's recommended to select automatic underscore by 6 because it automatically divides the records into halves, and each halves are tried until all the records are processed or only the failed messages are remained. Okay. uh, that's easy. And there is filtering and enrichment layer also. If you see in pipes, filtering is basically you can use event filtering to filter out any data before you send it to enrichment layer or target layer. For now, I'm skipping the filtering layer, but that's just.
And just for people to know, the filtering is super useful, because if you're only going to process a certain amount of your records, instead of sending them to another service and then drop them there, if you filter them over here, you're not paying for any of those records that you're not actually going to process. So yeah, when people ask me about filtering, I'm like, filter as soon as you can. It's just going to save you money. And yeah, this is just configuration over here. It's easy stuff to set up.
Exactly. You just have to use event, like if you're familiar with event patterns in EventBridge rules. So it's a similar logic applies even in the Lambda mapping filtering, like whatever logic applies, so you can use same kind of event pattern matching and filter those records. And next, there is an enrichment layer also. If you want to enhance your data for like certain kind of reasons, like if you want to store into time streams, and before sending it to the target, you can absolutely choose serverless options where you can send that to the enrichment layer, AWS Lambda, step function, API gateway, API destination, whichever you'd like to use and familiar, like in your current environment. You can use that to enrich the data and send it to target. So this is also again optional, and I'm skipping this for the demo and moving on to target. So I'll go ahead and select Timestream for live analytics. That's where we wanted to ingest ultimately, right? So for the target databases, we have created vehicle and metrics. I'm going to choose that. And for the table, vehicle metric table, I'm going to choose that. Okay. So there is a default time column in Timestream, right? So what we're trying to say as part of this time field type is how you are getting the data. How is your time field? Is it in the epoch format or is it in the timestamp format? So I'll plan to send the data using Kinesis data generator in the timestream format, and I've saved the format already, which I'm going to copy paste here. So this is the format we'll be using to send the data into Kinesis stream. And coming to time value, so this option is basically where we are explaining like which of your values that you're sending to Kinesis it becomes the time value. Like when does that event happen? Like when is that humidity or temperature is being? So that's what we'll capture as part of it. So the way we define this one is $.data. So there is a $.data object within the Kinesis stream when it comes to pipes. So there is a $.data object, and we access that object using this $.data.date, and we'll specify like what is that particular attribute as part of it. And there is a version value. We were talking about like dimensions and measures, right? So in Timestream, like if there is existing dimensions and you want to update like records for those measures, for what sort of reasons? Like it could be like your device went offline and there is some miscorrections you have to do. So if you want to update those measures, this is where like you'll specify like this help you to like upset the records. So what I'll try to use here is let me copy paste and explain. 1 second. I'll use approximate arrival timestamp. So what this basically happens is, so whenever a record is received in the Kinesis, there is an approximate arrival timestamp recorded to as part of it. So if you want to update the records, right? So what happens is this will have like latest arrival timestamp, and with the existing dimensions and time value, if there are any major changes, those records will get updated. Okay. And
so in a way, can this be used for a bit of idempotency or something? If, for example, something breaks and you need to read from the Kinesis data stream again and populate the database, that's just going to see an updated record or same record, and you can change values and just. I think I'm mumbling over my words, but you've got a sort of a unique value that you could. It knows just to automatically update rather than add a new field.
Yeah. So
record.
Exactly. So the version value is basically like if you have a record already existing in database, there is a version value stored to it. But if you want to update that same record, then your version value has to be changed. So that way we know that you are updating an existing record. Okay. So the version value, let's say if was for the previous record was like 1, then it should be greater than 1. So using this column, right, so always the arrival, if the data is new, it will obviously have the latest arrival timestamp. So that way we know that it's and if it has like same dimensions and time, we know that it is an upset rather than an insert.
Oh, cool. That's a nice part of it, I think.
Yeah. Yep. Okay.
That means when you're reading from it, you always get the latest value. You're not having to read a whole set of records sort by something and then select,
Exactly.
whatever.
Yep. So coming to data, you have to define like a data model. Like basically, you'll say like, what are my dimensions and measures? You can use a visual builder also, and say like, this is my dimension, this is my measure, and like when we're talking about the default measure and name column, you can define it absolutely. But like for saving time, I've already have like a JSON template I've generated, and I can walk you through the JSON template. So there are like options, like you can use visual builder or JSON editor. For this time, I'm using JSON editor. So here, what I am saying is there is a dimension mapping and there is a measure mapping. So vehicle ID and vehicle type. So that's what we plan to ingest, right? Like vehicle data. So the vehicle ID or vehicle type will become the dimensions, and the other, like if you're capturing miles or engine status, battery level, those kind of become measures. And there is a default measure underscore name column. That's what we're talking, right? Which is like a default partitioning. So we are not using default partitioning. We already defined like a customer defined partition key for this table, right? So for the default measure underscore name, I'm just specifying it as metric. Okay, not to confuse. So if you're using customer defined partitioning, you don't have to worry about measure underscore name, is what I'm trying to say. Okay. With that, so we have set our source, we have set our target, then we can move on to set our do or like pipe settings before we create the pipes itself. So there is an option like if you want to activate the pipe immediately or not. So I'm going to turn it on for now. And there should be a role associated to how this pipes can read the data and ingest the data. So there is an option to create a new role as part of this creating pipe. Or if you have like an existing role that you want to use, that's totally an option. I would like to use like create a new role for me, so that way it actually creates like minimum minimal permissions to perform the operation. So there is a retry policies and dead letter queues. So what we generally recommend is for the maximum age of event, like you try to put like 30 minutes or higher, so that like if there are any transient if the records that are older than 30 minutes, they're automatically sent to DLQ. And similar to retry attempts, we say to keep it like 10 times at least if there are any transient issues that will get fixed, and if there are any permanent issues, that it will obviously send it to the DLQ. And for DLQ, I'm choosing like an SQS queue in my account itself. I've already created a SQS, so I'm just choosing that. For coming to logs, where you want to export the logs to see what's happening, there are a few options here. CloudWatch logs, data fire or stream S3 logs. That's where I can read my data, and there are multiple levels of how you can have like log levels. So so errors are only for errors, and like obviously in general like coding terms, whatever is, it's similar analogy here. So I choose info because I want to have like more details. And you can include the execution data, but like one thing you have to be careful here is it might contain like sensitive information. So for this demo I can include it, but like based on your use case, if you have sensitive information, I recommend not to include it. And
yeah, that's very helpful for troubleshooting, because this is a managed service, this is a way that you can exactly see the records that are coming in, transformations, and all that stuff happening. So
yep, that's right. CloudWatch logs, you can again same option. You can choose an existing log group, or you want to create like a new log group. So I'm going to create a new log group. Okay, and just want to specify a different name. Okay, create pipes. Okay, I see it's creating now. Input parameters. Okay, we see the error saying that input parameter is invalid from the request to. But, okay, we can troubleshoot that. Second, let me go ahead and choose a different. Okay, the pipe. Let's see if we are able to. Okay, that's nice. Now it's running. There might be some issue with I've done like this test many times, and maybe like some issue with DLQ. It's,
I think it should probably be the IAM role not having the permission to the new
yeah,
DLP.
something similar to that. Yeah. So I think, yeah, we were able to fix that like automatically. We just chose like a different DLQ for now, and we see the status as running. Okay, that's good. Now we can go ahead and start ingesting the data. S- So as I said, like I'll use Kinesis data generator. I've logged into the UI already, and I'm choosing. So this is where I'm performing my all the operations where I created the pipes, and also my tables are in US East one. So I'm accordingly created a delivery stream there. So I'm choosing that delivery stream. And I was talking about the template, right? Like if you see there is connection time, and you can define how you want to send your test data, and then how you can generate like random values. So if you go back and like what I was trying to explain, like this is where I'm saying dollar dot data dot connection time. This is where the event time is happening. So that's what the ultimately the time will be stored in time stream. And there is vehicle ID and vehicle type, which are like dimensions, and the others are like measures. Okay. And I can test the template also to see like how the data is being generated before I can actually send it to the stream. Okay, send data under records. So it started sending the data. Now I can come back here. Still just, okay, I still don't see the errors being ingested. Can go back and check here if I have done the right mappings. Vehicle metrics, vehicle table. Okay, let me troubleshoot what's happening here. So you can go here.
As you can see, we're live on Serverless Office Hours. We're not making it all up with canned demos.
Okay, I see. There is a permission issue again. So permissions are set correctly to allow to write into while creating a subscription. Okay, that's no, that's not an issue. Actually, it might be an info. Let me see what's happening here.
Interesting, because it normally should be quite well. It's going to be quite verbose with the logging anyway.
Yeah, yep, that's what I'm writing for. Let me open the CloudWatch logs actually and see if there is some kind of issues here. Or let's see on the Kinesis one if we have the data coming in. And this is the stream. Metrics.
So here we go. If you're watching and you're yelling at me, going, "That's it, let us know."
Yep. So yeah, we definitely see records being coming in. That's why we see some like 400 records being retrieved.
Cool. So at least we know
There's
messages are
something
getting
to
to
do with,
Kinesis.
yeah,
We've
yep,
definitely got
yep.
the right
Checking.
Kinesis stream that we're pulling.
Yep.
But don't you want to check the IAM rule permissions just to make sure that those are set up correctly?
Yeah, sure. Let me do that quickly. This is my role. Okay, let me expand this one, expand this one, expand this one. For the time stream one, I have vehicle metrics table. I think that's exactly what I'm trying to do, right? Just want to make sure I have the right one. Yep, that's the right one. And vehicle metrics. Yep, that's right. Okay, we will do this one. Let's give a send message. Okay, this is night. I'm able to send it to the right SQS one. For Kinesis, I have the Kinesis one. Oh, it doesn't have a CloudWatch permission. I don't see a CloudWatch permission. Let me see if I can add that. Touch policies. CloudWatch. Yeah. See if I have an existing policy that I can use. Second. I don't see any difference with the permissions as well. Let me see if there was any delay loading the data.
Definitely haven't got a spelling mistake on the actual on the time series database or table name. No, you selected them. Yeah, you sort of manually select them.
Vehicle metrics. Yep, I have the vehicle metrics and vehicle metric table. So it's not like I've defined it there itself or something else that's going on.
Vehicle. The target table is vehicle with a CEL. VIHICEL. So that may on your query. Oh no, that is correct.
Yeah, that looks good for me because that's what I tried to do.
It's here to annoy us.
Yep, for sure.
Promise you this does work. We definitely see that.
Yeah, it just worked like 30 minutes back. It's a demo course.
Yeah, definitely. I mean, it's probably going to be something either not running to CloudWatch logs. I mean, unless we take off CloudWatch logs or the SQS queue, it could be if it is a permissions thing. But then a permissions thing would also log. The pipe would log that.
Exactly. Just want to make sure. Just want to make sure. What's my vehicle? 1 second. Metric table. What's my partition key? Vehicle ID is my partition key. Did I use the right one here? Yep, that's correct. Did I send the data correct? Yeah, that looks correct for me. We're definitely getting the data ingested into Kinesis because that's what we see here.
Yeah.
There is something happening within the EventBridge Pipes, which I'm trying to troubleshoot here live. Let's see if this gives any details.
Yeah, because we did quite a few thousand. It's not as though the batch size hasn't been reached yet. Batch size 100.
I can pump more data. That should not be a problem. Like I can keep sending the data.
Do you see any more logs even on the pipe side?
Pipe side. Let me see. 1 second. Nope, I do not see any permissions on the pipe side. So what I'll try to do is I'll add permissions for now.
Yeah. Ashish Pendione joining us on Twitch. Thank you. Yep. When in doubt, it's always a horrible thing to do. It makes you feel slightly icky, crawly, but yeah, broaden the iron permissions.
Yeah. Administrative. Or I can add an inline policy if that's. See if that. For temporary sake, I'm gonna.
I'm not watching. I'm not judging.
Yeah, I'm just add administrative access to see if that helps in any way. just for testing purposes. And let's go back here. Put the test. Nope, still no luck. I can keep pushing the data. Yeah, this is pushing the data. This is working. Let's see if we have more details in the QA system. In the logs now.
Yeah, definitely something strange that it's not also logging that there's an error.
Yeah, exactly. There's something definitely. Yeah.
Unless we haven't selected the right source Kinesis stream.
Yeah, I've selected the right source. Let me see if just want to make sure. So I have the US East one here, and that's what exactly it is. And vehicle underscore metrics is what we are sending. And in EventBridge, I said like vehicle underscore metrics. And same to do with in the streams as well, like vehicle underscore metrics. This is where we are receiving, and I only have like a single stream, and that's where the data is being pumped to.
Sometimes these things happen. That is what it is. Normally, what would happen, like when you're doing a cooking show and you have everything prepared at the end, we would have a database which we'd be querying records from, and then it would all be there. But hope you can sort of appreciate that, it was a bunch of configuration in EventBridge Pipes. You're not having to run Apache Flink. You're not having to run a Lambda function as well. Yeah. And actually, thanks very much.
There's a blog also, like if you wanna like share.
I will link the blog as well. And there was a question as well. Yeah, about the CDK. So I'm hoping to see Kinesis to EventBridge Pipe to Timestream integration available in the CDK. I'm not sure if that's available yet. But I'm sure that would definitely be coming soon.
Are you familiar, Jatin, if the CDK is already available?
Yes, it will be available. It should be available shortly.
Perfect.
Few weeks.
Perfect. Excellent. Yeah. So there's a cadence with SDK and with CDK, and that will come out as soon as possible. So yeah, there's a blog post which is explaining how this all works. Is there? Yeah, and actually, as you rightly said, this is why I use IIC, especially for demos. True, but it's also partly to show how quick and easy it is meant to be able to set up, which is all working before. So either route you go, you may burn yourselves. But we got as far as we could. So Balwant and Jatin, thanks so much for spending time on Serverless Office Hours here today. Fascinating world of time series databases. It's something I'm wanting to learn more about and finding use cases for them. It's great that we can link up EventBridge Pipes, and we can also do Timestream for live analytics. I know Balwant literally 2 minutes after this is going to message me and go, I got it. It was some silly thing and we didn't see it. Which is a live demo.
I'm pretty sure that.
Yeah, exactly.
Yeah.
Well, just before we say goodbye, coming up next week, we're actually talking about a fast and secure front end. So this is a way where you can do a whole bunch of customization to build front ends on AWS using CloudFront and Lambda at Edge, I think, and maybe CloudFront functions. A whole bunch of things we're going to throw together, which gives you the ultimate customization for building front ends. So Cornelio is joining us again, and Ashraf will be joining us as well to talk about that next week. But yes, there was also a question. Actually, she was talking about regions. I think it was India as well. Any plans to bring Timestream for live analytics to AP South 1 and 2? So I suppose region expansions are always on somebody's list, and yeah, they'll be rolling out as soon as we can. Cool. Well, we don't have to announce when these things are going to come out. I know region builds are a very important thing at AWS, so they'll come out as soon as we can. So hopefully as soon as possible. Balwant and Jatin, thanks so much again. Really appreciate your wisdom. Their details are in the stream notes as well if you want to connect via LinkedIn, or send me a message as well if you have any further questions or comments. And yeah, enjoy building time series databases. Thanks very much for joining us, and see you same time, same place.
Thank you.